Hello, in this module we'll be going over LeetCode container with most water problem, and in this problem you are given an integer array with a height of length n. Okay, now what that means is there's an input array and you want to find two endpoints of the ith line on this grid here where two walls and the distance between those two walls is a global maximum. So the container contains the most water in this case, and you can use a variety of different methods, but in this module I'm going to be first showing you a brute force solution that I'd use in O of n squared, and then of course the optimized solution in O of n. So this example is given to you by LeetCode, and you can see that these red bars indicate the lines where the volume is maximized. And in O of n squared, what I'm looking to do is to find the distance between pointer j and pointer I. So subtracting j minus I will give you the distance. And then we want to multiply this by the height of the wall. So in this example here, there's the first wall, which I'll indicate by h1, and the second wall by h2. So h1 and a2. And obviously water will overflow the container if the water levels are greater than the minimum height between the two walls. So we actually want to multiply this by the minimum of h1, h2. Okay, so the idea works the same in both the brute force and the optimized solution. And in the brute force solution, you'll get something in O of n squared, because my solution is to loop with two loops from 0 to the end of the array, and we do that twice. We check so long as the pointers I does not equal to k. Well, let's use something else. N does not equal k. Then this is a valid container in the set of all subsets of containers. Okay, so let's go ahead and implement this in O of n squared using my brute force solution. So very simply, we want to do a couple of things here. So we want to initialize whatever we want to return. So I'm just going to name it R, and we'll start off with 0. And we want to loop from the beginning of the list to the end of the list. And because we need two walls, we need to do this twice. But this first loop will allow us to first initialize the first container wall. So that would be the first container height, which I'll denote h1. And h1 will be the height of the endpoint of the ith line at I with height I. Okay, so that is h1. And of course we want to initialize another loop with j, this loop variable j here. And I'll denote the container wall by h2, so height j. And as I mentioned, the volume will be the product of the minimum height lefts between h1 and h2, so finding the min. And then, so in JavaScript, we use the math library, math.min, and you can input two different or multiple values here. That's what's great about JavaScript. So we can do h1, h2, we get the min, and that's just the maximum height for which the water will not overflow. And we want to multiply that, of course, by the distance between the ith and the jth wall in the array from 0 to height.length. And I'm going to do j minus I. Due to looping over in this manner, I'm going to wrap this in an absolute function because we just want the distance between the 2 points. Perhaps at some point in the loop, j might loop over to I. I'm not sure. Putting this just takes the distance between the two containers, so we don't really care in the bare bones solution if j is the right pointer or I is the left pointer, but this is something we'll need to consider in the optimized solution. So here's the volume, and very simply, if the volume is greater than the global maximum R, then we'll need to update the global maximum to the volume. And we really only want this to run if I does not equal j, because otherwise we'll be left with a container of width 0, because the width is j minus I, and if j is equal to I, then j minus I is equal to j minus j is equal to 0. So I'm just going to do a quick little check here that if I is equal to j, then we'll break from this loop and we'll continue looping. Finally, of course, we'll return the global max after looping over the entire array in O of n squared. Run our test cases, and we see that it is accepted. And submitting this will pass, but it will take too long on arrays of a very large size. So I'll just show you here that it works for the majority of cases, but the time limit exceeds on 5 of them. Okay, so the optimized O of n squared solution is one where we use the technique called the sliding window. Now, the sliding window is reused a lot in these algorithmic problems, but the point is that we take our entire array, right, from pieces, and it starts at 0 and it ends at array.length. Okay. And we want to initialize a left pointer as 0, and we want to initialize a right pointer. Now, the volume calculation is the same. We want the length or the distance between the left and the right pointer, and we want to multiply this by the min of h1 and h2. Okay, so really simply, it's just in this two-dimensional case, just length times height. Now the trick is, because we're using a left and right pointer, we really only need to loop over the list once, because we start from the left side and the right side, and we initialize the global maximum, and we only update the global maximum if the local max, which is calculated by vlocal, so VL, and we only update the global max if VL is greater. in the sliding, so the sliding window actually allows us to not update, not check as many times as we do in the brute force case, because we can update individually the heights of the walls, and we traverse in the direction. So we update the left side and we uh, decrement the right side. Okay, and we do this only if and only if the left side is less than the right side. So the pointers do not overlap, and this is why the solution is in O of n. There are faster solutions, of course, but this one works in O of n, so it checks out for what you need to know. So we increment the left side and we decrement the right side if and only if the left then is less than the right. And because now we have control over the heights, we have some more information on which side that we do want to traverse. So whether going in the left direction or going in the right direction. Okay. This way we find the local maximum and then finally the global maximum. So same setup here. We'll have our global maximum that we want to return. So simple setup. And like I said, we want to initialize a left and right pointer. Okay. Height.length -1 because we want to take the value of height at r and we don't want to surpass the boundaries. And we do this in a while loop. So as long as the left side is less than the right side, we're good. Because if there's any overlap, then that subcase actually has already been accounted for because they overlap and the right becomes the left and the left becomes the right. It's symmetrical. Okay. Now we want to find the volume, and how we do that is by first finding the heights. So the first height is the height array at the left pointer, and the second height is the height array at the right pointer. The distance between these two will be denoted by d, and this is just equal to r minus l. We can be sure this is positive because it already checks out that left side, the left pointer is less than the right pointer. So the volume is equal to the minimum between h1 and h2. Same situation as in the brute force case, accounting for overflow. And we update the global maximum if the volume is greater than res, which is our response. Yeah, I'm used to using res coming from API background. Now, if volume is greater than res, we update it. So, starting with our container, in this example, we have our left and we have our right, and immediately our first response, the first local maximum, which is obviously not the global maximum, is this container here. And this water level is, in this example from this graph, you can see not the largest. Now, how do we know whether or not we want to increment the left pointer or decrement the left pointer? So we do this in a series of if statements. So we know that um, if the height is greater, then we want to go in the direction where the height of the container is greater. So from the left side or the right side. And we want the height. So if the left side height is greater than the right side, that means that we need to try to improve the right side. And we can do that by searching deeper inwards from the right side. So if the left side is greater than the right side, we want to increment the right pointer, decrement the right pointer. And if the left side is less than the right side, we want to increment the left side. Okay. Now, in the case where the heights are equal, this is an edge case, obviously, but you see if we get our input array and perhaps L, our left pointer is 8 and our right pointer is 8, we need to be sure to add a equality operation just so that the loop continues looping. Otherwise, the right is going to be stuck on the right side, and the left is just going to be stuck as well. So we add this equal sign. Now, finally, we return the res, which is the global maximum. So this here is the O of n solution, and we can run our test case. Passes these two, and the other 16 that were given as well. So solution for container with most water using the sliding window technique. Thank you.